This is lesson 63, VHDL example 38. And in this example, we'll implement the edge-triggered D flip-flop with set and clear. This is going to be similar to the example we did in lesson 62, except we're just going to add the set and clear that we talked about in lesson 61. So here's the circuit. We'll implement it in exactly the same way. We just add a set input and a clear input, and then we'll write the logic equations. The only difference from the previous example is that in this output for F1 we're going to add AND not set, and then here we'll have a AND for F2 and AND not clear. Also, the not set goes into F3, the not clear goes into F6, and F4, the not set also goes into F5. So we've added these not sets and not clears in the logic equations, and then we can go ahead and simulate it. And notice that in general it behaves like the edge-triggered D flip-flop, that is, Q only changes on the rising edge of the clock. Here D is 1, so Q goes to 1 when D is 1, you see on the rising edge of the clock. But now we have the asynchronous clear, so if clear goes high, even though the clock here is low, Q immediately goes low. And it stays low until the next rising edge of the clock, in which case Q goes back high because D is high. We also have this asynchronous set. So when the set goes high, Q immediately goes high, even though the clock here is low, and it remains high until the next rising edge of the clock, in which case it gets the value of D, which is now 0, so Q goes back to 0. So this simulation shows that that circuit in fact does implement an edge-triggered D flip-flop with an asynchronous set and an asynchronous clear.